All right, guys, so this is the start of chapter 11. And in chapter 11, we're going to do like some areas and circumference of circles, things like that, area of sectors. And then we're eventually going to move on to like volume and surface area and things like that. But this section, this is section 11.1, is about circumference and arc length of circles. So hopefully a lot of these will be review for you that you've done maybe in 8th grade or maybe even earlier. But let's get started. Now, I do understand some of these vocabulary words are review, but you should know them. Anytime we're beginning a new chapter and we're kind of emphasizing them again, I always put them on here. So hopefully from last section or from last chapter, you remember that a circle is the set of all points in a plane that are equidistant from a fixed center point. Okay, and then a diameter is simply a chord that contains the center of the circle. So it goes all the way across. The diameter is the longest chord in a circle. And then a radius is a segment that has one endpoint, who can't spell, as the center of the circle, while the other endpoint is on the circle. So a radius is basically double a diameter, or sorry, a diameter is two radius put together. The circumference is the distance around the circle. A lot of people like to think of it as like the perimeter of the circle. So if you're walking around the circle, that'd be the circumference. Arc length, it's just the measure, it's a part of the circumference, I guess. Okay, so it's how far are we going? We may not be going all the way around, which would be the circumference. Maybe we're going a fourth of the way around. Okay, so we'd find the arc length of that arc. Radian, this is just a unit of measure for degrees. So kind of like temperature, we have several ways we can measure degrees. We're going to measure for, how about this? For angles. Sorry. We've been using degrees, but we're going to show you how to convert degrees into radians. So radians, a unit of measure for angles. And then pi, I know you've heard of it. The symbol is here. It's roughly 3.1415. It goes on forever and ever and ever. Everyone knows pi. But most people don't know how we got pi. And pi is simply the ratio of the circumference of every circle to the diameter. All right, so the circumference of a circle, guys, it has two different formulas here. I just like to use this formula. One, because I can't remember both formulas. If you can remember both formulas, that's fine. This is the other formula. And notice they are the same thing because one diameter is the same thing as 2 times pi, or 2r. One diameter is 2 radius, so they're the same thing, just written differently. But I'm always going to convert back to this formula here. All right, so let's look at this. Example 1 here, it says find the circumference of a circle with a radius of 9 centimeters. Okay, so our radius is 9. So anytime we have circumference, we can find the circumference by 2 pi r. So here we're just going to plug r in. So c equals 2 pi, and our r is 9. Okay, so if we clean this up, 2 times 9 is 18 pi. So if Big Idea says exact, this would be exact. Okay, we don't put pi into the calculator because at that point we're rounding it. This isn't rounded, this is exact. If it wants it rounded, that's when I would put 18 pi into the calculator, and you should get roughly 56.5 centimeters. This here is rounded. So depending on what Big Ideas wants, if it wants exact, keep pi in your answer. If it wants rounded, put pi into your calculator and get a decimal. All right, so part B says find the diameter of a circle if the circumference is 17 feet. Okay, so once again, circumference equals 2 pi r. But here I'm given my circumference is 17, 2 pi r. I want to find my diameter. So if I want to find my diameter, I first got to find my radius, okay? So divide both sides by 2 pi. So my radius is 17 over 2 pi, okay? Well now, to go from radius to diameter, all I would have to do, 17 over 2 pi, is multiply this by 2 because the radius times 2 is your diameter. And when I do that, these two 2's would cancel, so I'd get my diameter is 17 over pi. Okay, so this would be my exact answer. If I want rounded, I would put this 17 over pi into my calculator, and I would get roughly 5.4 feet, and this would be rounded. All right, so let's talk about arc length, okay? So we know an arc is just a part of that circle. So if I'm looking at, I don't know, say AB right here. To find the length of AB, I'm not talking about the measure of AB, I'm talking about the length of AB. That would be the arc length, okay? So we have these formulas we can use. I like to say that arc length equals the proportion of the circle times the entire circumference of the circle. Okay, now if I break this down even more, I get arc length, I'm going to abbreviate, equals the proportion of the circle can be found by the central angle over, well, all the way around, the part over the whole, so the part all the way around is 360. So the central angle over 360 times 2 pi r. All right, let's look at example 2a. So I want to find the arc length of arc AB. Okay, so my arc length equals central angle over 360 times my circumference, which is 2 pi r. Okay, well, I have all these components. So my central angle, here's my central angle. So 60 over 360 times 2 times pi, my radius is 8. Okay, now I'm just going to simplify this one step at a time. So 60 over 360 is just 1/6. 2 times pi times 8 is the same thing as 2 times 8 times pi, which is 16 pi. Okay, think of that over 1 if you want. So if I put them together, I get 16 pi over 6. My 16 and my 6 reduce. So 8 pi over 3. This would be my exact answer. Guys, and the length, I'm still talking about centimeters. All right, let's do example 2 here. So arc length equals central angle over 360 times 2 pi r. Okay, I want to find the circumference of the circle. Okay, so because I want to find the circumference of the circle, 2 pi r is the circumference. So rather than putting 2 pi r and double doing steps, I'm just going to put times c, circumference. So now I just want to solve for c. Right here, notice I'm given the arc length. It tells me that from x to y is 4.19. Okay, it's 4.19 inches. So the arc length is 4.19. That's going to equal the central angle over 360 times my circumference. Okay, well, 4 over 360, guys, is just 1 over 90. Okay, so here all I have to do is multiply both sides by 90, because when I do, that goes away. And when I put that into my calculator, I get 377.1 equals my circumference. All right, now here I want to find the measure of RS, not the length of RS, the measure of RS, which is in degrees. So if we think about that, the measure of RS is going to be the same as the measure of this central angle. So if I solve for the central angle, that'd be the same as the measure of RS. So arc length equals central angle over 360 times my circumference, which is 2 pi r. Okay, now my arc length is right here. It gives it to me. Okay, so I'm going to plug that right in for arc length. So 44 equals my central angle, I don't know, I'm going to call it x over 360 times 2 times pi times my radius, which is 15.28. Okay, now because I have a decimal here, I'm not going to try to make it look pretty. Okay, so I'm just going to go straight to the math. So I'm going to first multiply both sides by 360. The reason I do that is to get rid of my fraction. Okay, so 360 times 44, I put that in my calculator. That's 15,840. That's going to equal, we're left with x times 2 times pi times 15.28. Okay, well, I can go ahead and multiply 15 times 15.28 times 2, I get 30.56. Is 15,840. Okay, so if I divide this by 30.56, I get roughly 518.2 equals x times pi. If I divide it by pi, I get roughly 164.98, so I'm just going to say roughly 165 degrees. Okay, so there's my central angle. My central angle, remember, is also the measure of its intercepted arc, so that would also be the measure of arc RS.